Welcome to a code report solution video. In this video, we're going to be covering the solution to Byte from the CodeChef October 2018 long challenge. The problem states, in the magical land of Byteland, there are three kinds of citizens. The first citizen, a bit. 2 milliseconds after a bit appears, it grows up and becomes a nibble, i.e. it disappears and a nibble appears. 2, a nibble. 8 milliseconds after a nibble appears, it grows up and becomes a byte. And last but not least, 3, a byte. 16 milliseconds after a byte appears, it grows up, splits into 2 bits, and disappears. Chef wants to know the answer to the following question. What would the population of Byteland be immediately before the time n milliseconds if and only if 1 bit appeared at time 0 milliseconds? Help him and find the population number of citizens of each type. And note that the constraints for this problem are pretty small. T, the number of test cases, will be between 1 and 10 to the 4, and n, the number of milliseconds that'll pass by, will be between 1 and 1600. So let's take a look at some examples. So here's the example from the problem that CodeChef provided us with. We have 2 test cases, and then the number of milliseconds we have is 2 and 3. So pretty straightforward. You can see here that after 2 seconds, we still only have 1 bit, and then after 3 seconds we have 1 nibble. So bit is represented by the first column, nibble by the second column, and then byte by the third column. So honestly, these examples are pretty poor. It doesn't show you much about the problem, but really what you want to see is full-blown sort of, after 1, 2, 3, 4, all the way up to 30, which completes like a full cycle of a bit going to 1 nibble, going to 1 byte, and then that byte going to 2 bits, and sort of we're just going to cycle like that. So if we take a look at that test case, here we have 15 test cases, 1 all the way up to 12, and then we skip up to 25 and show 26 and 27. If we see the output for this, it looks as follows. So you can see for the first 2 milliseconds, we still only have 1 bit. And then that, after sort of this, at the 3-second mark, that bit becomes a nibble. And then at the 10-second mark, which is 8 seconds after the time when the bit turned to a nibble, it turns to a byte. And then we skip sort of over the middle here from 12 to 15. But then when we have 27, this 1 nibble converts to 2 bits. So we basically just have this cycle. And due to the constraints of this problem, we can literally just brute force this by looping through the number of milliseconds and performing this operation where whenever we have the current d, which will be equal to our current number of milliseconds modulus 26, whenever this is equal to 3, we are going to just swap the number in this value over into the second column. And the same thing for 11, we're going to swap the value from the nibble column into the byte column. And then whenever we hit the 26, right after 26, which is going to be a d value equal to 1, we're going to just multiply this value by 2 and set it in our bit column and then reset this to 0. So it's really straightforward. You just need to know about the numbers that cause a switch from bit to nibble and nibble to byte and then byte back to bit. So this is what it'll look like in the C++ code. I will keep track as sort of our number of milliseconds. And so as we progress through this, whenever d equals to 3, we're just going to swap these 2 values. This is the same thing as just setting the nibble value equal to the bit value and then setting this to 0. But because we always know that only 1 column will have a value and the other 2 will have zeros, we can swap. And so when d equals to 11, we can swap. And then when d equals to 1, it's slightly different. We swap and then we multiply by 2. In a different language that doesn't have the swap function, it just looks as follows. So this is Python here. You can see here L0 is being set to L1, and L1 is being set to L0. L1 is being set to L2 here, and then L2 is being set to L1. And then at the bottom here, we see the times 2 again. So it's pretty straightforward. This is just an implementation problem. And yeah, so let's take a look at our code solutions. So here's our C++ solution, and you can see at the top we're reading in our value t, and then we, similar to the last problem we covered, we loop through t, decrementing it until it hits 0. Then we have a vector of long longs, and this is necessary in order to pass the problem because our values can get quite large, and we just have 3 values in our vector here. So then we read in our n. We're going to loop from I equals 3 to I less than or equal to n. Note that we're starting at 3 because we don't need to do anything for I equal to 1 and 2 because we've initialized our vector to have the correct values for those cases. And then we just calculate our d, which is equal to I modulus 26, and then we just plug in our code that we saw from earlier. And then once we finish this for loop, we just output the values with spaces in between them at our indexes 0, 1, and 2. So pretty straightforward. Taking a look at the same solution, but in Java, it's not quite as nice due to the fact that we don't have a flexible comma operator in Java, so we need to break all this stuff out onto separate lines, but otherwise it's the exact same, just slightly different syntax. So reading in using scanner once again, initializing a list here, or an array instead of a vector, then we read in n, have the same for loop, do the same modulus operation on I to get d, and then we have the exact same computations happening here. So we don't have a swap function in Java either, so we're doing the L1 equal to L0 and then setting L0 to 0 and then the correct things for the other cases as well. And then at the end here, we don't really have a neat way to print this out all on one line, so a simple for loop will do. And last but not least, taking a look at our Python solution, here it is. It's once again the most concise of all of them. Reading in T, setting a list up, reading in N, and then the same for loop with the same operations inside. And at the end, we do have a nice way of printing this out, basically mapping each of the values in our list of numbers into strings and then joining them together by using space. And the last thing to talk about is the time complexity of this problem, which is going to be big O of t times n, which is quadratic, but like I said earlier, due to the low constraints of this problem, it will end up passing.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.